Assalamualaikum and good day. Okay, in this video, I will show you an example on power series solutions involving non-polynomial functions. Okay, for non-polynomial functions, we need to change it in terms of series. Okay, for A, show that the Taylor series expansion at x naught equal to 0 of fx equal to exponent to x up to the third term is 1 plus 2x plus 2x squared plus until infinite. Okay. Here, we just need to prove until the third term, okay, which it will be in this form. Okay, fx is equal to exponent to x. So, next find f prime x and f double prime x. The reason I do it just until f double prime is because we just need to prove until x squared. X squared means just until the second derivative. Okay, next, substitute 0 in f. Okay, so f0 equal to exponent 0 equal to 1. And substitute 0 in f prime x, we have 2 exponent 0 is equal to 2. And substitute 0 in f double prime x, we have 4 exponent 0 which is equal to 4. Okay, the formula for the Taylor series is actually this one. Please write your function. Okay, don't leave it as blank. Okay, so exponent to x is equal to f naught plus f prime 0 times x over 1 factorial plus f double prime 0 x squared over 2 factorial plus until infinite. Okay, so right now, just substitute the values that we have obtained earlier. So f0 is equal to 1 plus 2 because f prime 0 equal to 2. 2 times x divided by 1. 1 factorial is 1. Okay, f double prime 0 is 4. And then times x squared divided by 2 factorial, which is 2 plus until infinite. Okay, just simplify where needed, which is this part. It will be like this. Okay, simplify the 2. And thus, we have this equation. 1 plus 2x plus 2x squared plus until infinity, which has been proven that this statement is true. Okay, and then for B, hence, find the general series solution of the differential equation. This one is y double prime. I prefer to rewrite it in terms of this because much easier for me. Okay, plus 4y equal to 2. So the equation is actually y double prime minus exponent to x y plus 4y equal to 2. And we need to solve until the term x cubed, which means we just need to find until a3 about an ordinary point x not equal to 0. Okay, so right now, this is the equation. Okay, y double prime minus exponent to xy prime plus 4y equal to 2. Okay, the same one. Okay, x not equal to 0 is an ordinary point. So, we will be solving this equation using power series method. So, let y equal to summation n equal to 0 until infinity a n x power of n. Y prime is differentiate y with respect to x. We have summation n from 1 to infinity and a of n x power of n minus 1. And then y double prime differentiate y prime here with respect to x. We have summation n from 2 until infinity and n minus 1 because we bring the power forward. Okay, a n x power of n minus 2 because minus 1 in the power. Okay, next, after we let these summations, we need to substitute y prime and y double prime in the given dE, including the exponent to x that we have obtained earlier here. Okay, in terms of power series. Sorry, in terms of series. Okay, so right now, summation n equal to 2 until infinity, n times n minus 1, a of n x power of n minus 2, minus, this is the summation, this is the expansion for exponent to x. Okay, times y prime here, plus 4y equal to 2. So, for this solution, I choose to expand instead of continuing to solve in terms of summation, because we just want to find until a3. Okay, that means it's just a short solution because we just want to find the value until a3. So I decided to expand. Okay, the expansion for the first summation will be 2a2 plus 6a3x. And the reason I stop at here because the clue is here. Okay, we have the term, the coefficient a3 here. So, we just need to stop until this term and you don't have to expand anymore. Okay, for this one, can you please add? Okay, plus until infinite. Sorry, I missed it there. Okay, plus until infinite. So, this one minus, okay, this is the expansion for exponent to x, multiply with the expansion for y prime. Okay, as you can see here, I stop until the second term. Why? Because A3, the coefficient A3 is in x. Okay, we just want to compare the coefficient on the left and right just until x, because we can obtain the value of A3 when we compare the value for x. Okay, the coefficient for x. Okay, so I stop until here, and then plus for A0 plus A1x, and so this here I stop until the second term, because we just need to contain x here, because we want to compare the coefficients in front of x on the left with the coefficients in front of x on the right. Okay, because we has obtained A3 in that equation. Okay, next we just need to rearrange, expand. Okay, the first part, okay, sorry, can you please add, okay, plus until infinite. Okay, this is the same terms, but this one I just expand. Okay, which means here 1 plus A1, I get A1 minus A1 because here is negative. And then 1 times 2A2x, so negative 2A2x because times multiply with the negative in front of the bracket. Okay, next, okay, we just stop here because we have x. Okay, we want to compare the coefficients of x only. Next, 2x times A1, it will be minus 2A1x. And I didn't multiply 2x with 2A2x because it will be x squared. X squared, okay? So, we don't want to compare any coefficient in front of x squared. So, we just stop until here. Okay? Plus until infinite. This one is compulsory because of the continuous. Okay? And then plus for A0 plus for A1 x. Okay? Multiply the constant with the terms inside the bracket. Okay? And then what you need to do next is to rearrange. Okay? Write the terms in bracket for each coefficient. Okay, that means constant in brackets, in one bracket. Okay, and then plus another, open the bracket. Okay, the terms for x plus until infinite, that will be equal to 2. Okay, after that, simplify, and we have 2A2 minus A1 plus 4A0 plus 6A3 minus 2A2 plus 2A1x plus until infinite equal to 2 because we have simplified this part. Okay. And then comparing the coefficients here. Okay, we compare first the constant. Okay, we compare the coefficients on the left and right. Okay, we have constant here equal to 2. So everything for constant here, 2A2 minus A1 plus 4A0 needs to be equal to 2 because this is a non-homogeneous equation. Okay, so after that, make sure you rearrange and get the highest coefficient, the biggest coefficient on the left. Okay, that means the biggest one is A2. So A2 equal to what's the other terms. Okay, and then for x power of 1 here, we have these terms. Okay, this coefficient is A3 minus 2A2 plus 2A1, and we compare it with 0 because this is literally 2 plus 0x plus 0x squared plus, okay, everything is 0. Okay, because we just have this the only constant on the right. Okay, that's why here we compare with 0. Okay, so next rearrange, and since A3 is the highest coefficient, the biggest coefficient, we need to have A3 equal to the other terms. So remember the final answer, the coefficient that we obtain should be in terms of A0 and A1 only. Since we have A2 here, we need to substitute the A2 that we had found earlier in this term. Okay, and simplify, and hence we have these values for A3. Okay, next, y equal to summation n equal to 0 until infinity an x power of n. So this would be the expansion a0 plus a1x plus a2x squared plus until infinite. Okay, and then here you just need to substitute the value of a2 that we have obtained earlier and also a3. Then factorize a0. Okay, open the bracket, what's the term inside, okay, and then plus a1, factorize all the terms involving a1, plus everything that involves constant at the back. Okay, and that will be it, the solutions for this question. Okay, hopefully you understand the step and grasp understanding on how to solve a non-polynomial function questions for series involving series for ordinary points. Okay, thank you. Have a nice day. Assalamualaikum.